Welcome to the Building with Metal podcast, presented by McElroy Metal. Whether you're a contractor, architect, designer, or building owner, we're here to help you build better with metal roofing and siding products.
Ever wonder what really happens inside a roofing test lab? Well, at McElroy Metal, we're thrilled to have our own independent testing facility at our corporate office in Bossier City, Louisiana. And today, we're joined by our very own Hunter Langdon, who runs all of our in-house testing. Welcome to the show, Hunter.
Hey, thanks for having me.
Yeah, I'm looking forward to it. This will be fun. So, to get us started, maybe tell us a little bit about your space, how big it is, how long we've been doing our testing, just some of the basics.
Yeah, so we have a pretty large testing facility here at McElroy. We've been doing testing in-house for more than 20 years at this point. We used to have a chamber that was basically made of wood, and we started getting higher pressures, and we needed to increase the robustness of our chamber. So we actually were able to take over a facility here that was once an insulation building, and I've got a large facility here. I guess it's 50 by 100 in testing, and also in our training lab as well. So I'm very fortunate to have a large facility here, and I'm very happy most people just kind of leave me in here to do my thing. I get our work done, and I get our testing done, and I'm just the guy out there in the lab.
And that suits you well, and it suits all of us very well.
It's my favorite, yeah.
Absolutely. So, you just touched on something. It's our first squirrel, right, of the podcast. I hadn't planned on going there, but I hadn't really ever connected the fact that at some point we left wood framing and went to steel framing. Mm-hmm. So talk to us more about that, how long ago it happened, and again, a little more detail about why we had to make that move.
Yeah, absolutely. So before I arrived in 2015. I've been here for 10 years now. It was before my time, but we had a wood frame, and it sufficed for many of our tests, but it just became an issue where you could not keep that wood frame together. Steel, of course, is going to be stronger, and we're using structural and substructural steel in the new chamber that we have here. So it was basically you want the test to fail and not the chamber itself to fail. And then you're always increasing the pressures you can get as you make that chamber stronger and stronger. So we needed to switch over. So Tommy and a couple of guys at that time in the tech service department came in a weekend, and they built my large, nice chamber that I've had the fortune of installing on. I didn't have to install in a wood box on my knees. So yet another good thing for Hunter.
Absolutely. And so one of the reasons the wood frame used to work for us, but no longer did, was because as our panels systems emerged and improved, we were able to continually meet higher test limits. Is that correct?
I believe so.
Yeah.
I do believe so, yes.
Very, very interesting. Okay, so let's talk a little bit more about your current testing chamber. So talk to us a little bit about what size it is.
Yeah, so we follow the ASTM E1592 guidelines. They kind of dictate to us what the shape and span of the chamber is and everything. But in general, it's 10 feet wide by about 25 feet long. And I am able to do with that distance. I can do spans at 5 foot on center. Sometimes I need to do 3 spans, which is the gap between clip lines. Sometimes I might need to do 4. So a lot of times I won't use the entire 25 by 10 area I have available to me. I'll actually chop that down to either 15 feet or 10 feet, and I'll do various tests at various different spacings. But we need that big chamber in case I do need a full 25 foot long test. Okay. It's a lot easier for me to tote panels that are 10 feet long rather than 25 feet. So I tend to, if I can do a shorter test, it's just easier and faster.
Makes total sense. So who decides that for you?
It's going to be in the testing parameters. ASTM will tell us that if we need to do a 5-span test, that's going to be a clips at 2 foot on center, then I can use a 10-foot area right there. So it just depends on what the spacing is as to how much of the chamber I'll use. It follows in either we do 3-span, 5-span, or 10-span. That's clips at 5 foot on center, 10 foot on, or 2 foot on center, and 1 foot on center. It just depends on those clip spacings as to what I use.
Okay, that makes sense. And so do you just test one of our panels, or?
Well, Over time, I have tested nearly every one of our standing seam panels. I've tested our medallion lock, our Maxima ADV, our Maxima 2, 238T, 138T, wave, medallion. I mean, almost all of them, right? It just depends on what comes down the line. And in general, I'll test one panel many different times for many spans, many widths, many clips. So it starts to matrix out into a large number of testing. In my 10 years here, I've done almost all of the 238T tests that are possible. And now I am transitioning over into doing trap T testing for our newest panel, that's come out on the market. So I'm consistently running through trap T testing.
And so you indicate that you've done, multiple tests on the same thing. Why is that,
Correct.
Hunter?
For the ASTM E1592, what you have to have is a initial test to find what pressures it can withstand. The ASTM it's a test until you fail. Other test procedures may be testing up to a point. If you pass that, then it's good for this rating. ASTM wants to find out what the actual failure is. Well, if you just test one thing, you only have one data point. So that could be an outlier, and it might not be indicative of the reality of the test. So we want to test 3 of the exact same tests in order to get an average, to make sure that it is failing at the same spot every time. And that's where ASTM E1592 really gives us value, is now we're allowed to lower our engineering design. We can now use fewer clips because we know exactly where that panel is going to fail at. There's reliability and safety in knowing that number.
Interesting. Okay. And so I'm just curious, how often do you see that variable change where you really need all 3, or is that?
It's fairly rare. We have seen it. Sometimes you can have a spacing that just doesn't make sense. For instance, they will have tests that are a clip every 5 foot on center, and then you can do a clip that's every 1 foot on center. You can guess what 2 on center would be. That's called interpolating. Sometimes that interpolation doesn't land where you think it was, so we do need to actually check the 2 foot on center. Our 238T multispan has a strange little outlier when it comes to testing at 2 foot on center. And this is the reality we live in. Things don't always work out perfectly. It can be as varied as it wants to be. So yeah, it does happen where things don't line up, and by having that physical test right there gave us a lot of insight.
And so let's talk a little bit more about your chamber. And so you do a test. I guess let's back up. Walk us through a test, if you would. From the day, the day before, and how you set up and just your test, and then what happens afterwards.
For instance, let's take a pretty common panel. We have a Maxima 216 panel. I'm going to do Maxima 216 at 5 foot on center, 2 foot on center, and 1 foot on center spacings. Each of those are 3 tests. So I'm looking at a block of 9 tests to do if I want to test everything. Coming in, I look at my chamber. I say I've got a 10-foot wide chamber. I set down eave plates in on the sides and the eave of the chamber so I can fasten down the edge. You can think of the chamber basically as a box and the panels as a lid to that box. So I have to cut a panel in half and fasten it down on the side, and then I install on top of pleated plastic. That plastic is there so that when you inject the box full of air, we can simulate negative wind uplift pressures by increasing, pressure from the inside. I have a plastic barrier. I install panels on that barrier. I seam them if they need to be seamed. I get to the end. I seal around it. I put down a large metal angle that seals, and then I'm ready. The test is airtight, and it's ready for the engineers to come in and inject the air that we need into that to simulate the wind uplift. So in general, I'm doing what our installers would do just in the field, laying a panel and continuing on. So there's a lot of overlap in just I'm laying panels down.
Okay. And so how is, a few follow-up questions here, how is that air applied?
All right, so we have a blower. It is a large, a blower that just crams air into the chamber itself. It has an impeller on it, and it's driven on our, what do we call it? It would be our blast shield that we have in front of the chamber. We have a large controller unit that will take that, put in air pressure, and then we have 2 manometers that are reading pressure at different ends of the box. They're going to look at that manometer and they're shooting for a specific pressure. They'll increase or decrease the pressure on the controller unit. And we're trying to reach to a certain pressure and hold it there. I think it's for 60 seconds. It's for a minute. I might be wrong on that. The engineers know a lot of that, a lot, better than I do. I build the test. So we'll hold that pressure for a minute. And then if it doesn't break in that point, we relax it and then we increase pressure. And we will continue increasing the pressure until we have failure, until the panel fails in some way.
Okay. And what are the most common points of failure you see? Or does that vary by panel?
It will indeed vary by panel. Some panels, the seam will de-seam and it will come off. Other panels, the clip will come off of its own base, or the seam will slip off the clip. There's several different ways that the panel can fail, but generally something will deform and something will lift off of the system, and I can no longer keep injecting air. It just will tear apart. It falls apart for the most,
Right. So you get to blow things up every day.
Yeah, absolutely. I come into my shop in the morning, I do a couple of stretches to get ready, and I install in this nice air-conditioned facility. I listen to books, and I make sure that I'm doing everything. It's very tedious to make sure that you do everything correctly and consistently as you install. And yeah, I call the engineers in. I say, hey, y'all come destroy this. And when we do testing takes about an hour and a half or so. So it's a good time for us to get together and talk about, things moving forward and to have a good bonding time with everybody out in the lab.
Absolutely. I'm sure that's probably one of their favorite parts, right?
Oh yeah, they do. They look forward to it. They'll let testing happen at Friday in the afternoon. Just like, it's a good end to the day.
There you go. Get away from the spreadsheets and into real world a little bit.
I can imagine. Yeah.
For sure. So let's talk a little bit more about the plastic. You talked about this pleated plastic. So what kind of specs is it? Do we control that? Does ASTM? How do you install it? That sort of stuff.
Yeah, so the plastic I'm using is a 6 mil poly, and that is dictated to us by the ASTM testing procedure. I would love if I could use a thicker plastic, because one of the things that I've got to make this chamber airtight, and if I drag my feet and I make a lot of holes in the plastic, then it won't stay airtight, and we get up to a higher value, and it doesn't blow. I've just got a leaky system. So that plastic, we've gone through manufacturers. We used to have a 6 mil Husky plastic, and over COVID, many recipes for many products changed over COVID. Paints were hard to come by. Your Saran wrap doesn't Saran wrap as good as it used to. Things like that. And I saw it in the plastics. I had some tests that failed because the plastic just perforated. It just popped, and it never done that before. So a couple of years back, I had to order plastic from every 6 mil polyplastic manufacturer, and I tested that plastic, and I came out with Uline being the winner out of 5 or 6 places. And hopefully they don't change their plastic, but ultimately I'm using it for a different purpose than is used in the industry. This goes under concrete to act as a vapor barrier. That's where the industry uses the 6 mil poly for, and I'm using it as a balloon, as a barrier for air, right? So it's something that everybody that does this same test is probably going to have that problem. I haven't talked to other people and what plastics they use, but yeah, it's a very important part. And I lay down the plastic first and install panels on top of it. I have to put tape down any place where I think the plastic might get torn. And I have to be careful, and it's also slick to walk on, so I've got to go slow as I'm installing on that plastic.
Absolutely. So you talked a little bit about the fact that you can inadvertently rip the plastic. What else could go wrong, either during a test or during setup for a test?
Oh, so many things. I could take a break, come back, and forget that I put only one fastener in a clip. I've done that before. That's a simple, just bonehead move that means that the engineers come in and they blow it up, and it blows on one specific clip. You could use the wrong screw. Most of them are forgetting to put in fasteners. In any test, there's probably, 500 fasteners that get installed. And if I miss 1 or 2 of those, it that's a failure. The entire test is forfeit at that point. So I can have that. I can also have where the chamber itself were to fail. If the test gets high enough, the way we have the chamber made is I have hat sections that are being held down by metal plate. So I'm going to fasten to those hat sections. Well, that hat section might just squeeze out from the metal plate. And we've seen that before. So I had to take and put in a strip of metal billet that would hold it from getting squeezed. And, from time to time, it will still destroy itself in some place. And then I strengthen that place, and now it's not the weakest link in the chain, and somewhere else on the chamber might fail. And I just discover those as we go. Yeah.
So you're constantly needing to repair, re-inspect, and make sure that your chamber itself is
absolutely
physically strong.
Several years back, we were getting to the point where we couldn't get to as high pressures as we had been able to in the past, and I decided that we were going to just reseal the chamber. It took about 2 weeks of my life, and I got down in that chamber and I pulled new plastic on the bottom of it, and I sealed underneath everything with tape. And then all of a sudden we were able to get up to 80 inches of pressure, in those areas. And that was the fix. Okay. So we just look at over time what's kind of happening with the chamber. Another thing that's really interesting lately is, for the longest time, we thought the chamber was moving. This is an extremely large metal box. As you inject air into it, it actually inflates the bottom and the top. It has skin along the bottom of it, so it picks up like a football off a table. And it's inchworming its way across my floor. It's doing it about 1/16 of an inch every test. So here in about 100 tests, I'm going to be against the wall. You can't imagine something that big just lifting up, and it sets down in a different position. So it's walking across the floor every time we test.
So at some point, you're going to have to take it down and pull it back to its original shape or spot.
I had to go get equipment dollies about a year ago, and I moved it like 3 feet away, and it's moving even faster now. So I might glue it to the ground next time.
There you go. Okay, so you've done your test. You tested to failure, right? We talked about that. What happens if you don't like the results of your test, and you think it should have been better for one various reason or another?
That is one place where I do come into play, since I'm installing the test, and I always do the autopsy on them when I pull them off. I do get to see, hey, where I put fasteners at in this multi-span clip, it might be a little better if I put them on the inside. So I can do some small things that are just kind of installer variation to try to get it better. But we'll take a look at what occurred in it, and if we're in the product development portion, we can change things. We can get a clip that has a little bit longer this, or a different shape this, and we can try to increase stuff. But if we have a test that fails and it's way outside of the range the engineers calculate, or maybe it doesn't get to the previous test value, ultimately I just install it again and see if it was me doing something. But very often it's clear the test shows if there was a mistake that was made. Everyone is in there testing, and it blows early, and they look at me because I'm, the installer error is the biggest problem you can have. I just have to try to be consistent and do it that way. But ultimately we would retest.
Right.
And, see what happens again. And sometimes the numbers just aren't that great, and there's nothing that the material or myself can do about it. It's a design issue.
So I want to talk about that. I'm glad you brought up product development. So, up until now, all of our conversation really has been about products that we've already launched, right? And you're doing different testing for, job-specific stuff, et cetera, or new test requirements. Let's talk a little bit about product development. What's your role in that, and how do you help both McElroy and our customers as we develop new products, Hunter?
My role can be, I see there's an idea, there's something that can be made, or maybe something that can be improved, and I bring it up and we go through iterations. Maybe we get a 3D print of it, we take a look at it. Other times we'll have somebody, even sales, come to us with an idea. What if we did a panel this way? And I will test that in any way that I can. Like I said, I can be involved in it to the point where I can come up with parts and pieces of systems, or the engineers do that, and we test it, or we just get an idea from sales. Sometimes customers have things that they want to have tested, or a product that they're looking to develop, and they will come to us and talk, through it with us and how it would fit into our systems. So I mean, anywhere from creating it to implementing it to designing it. It's just wherever. I mean, that's the fun part. It was many years ago. Bill Wade came to me and he was like, "Hey, I need you to make this." And I spent a week trying to make that dream come true. Ultimately, I wasn't fruitful, but learned a bunch of things, and that's how research and development works. You're hoping that something magical comes out of this, and sometimes it does.
Right. And so, I think that's the fascinating part to me. And that would be,
Right.
I think, the funnest part of the job. You talked earlier, maybe I need to make this clip a little longer. Maybe I need to make the clip gauge different, right? Maybe I need to take and make my fastener, a different size, or the different length of penetration into the deck, all of those things. And sometimes for us, even it's maybe adjusting pan width, correct? So talk to us a little bit what you see in testing as you go maybe from like a 16-inch wide standing seam to a 24. Is there a difference in the values you get?
Yes. So the wider you go with the panel, the weaker it becomes. Your seams are where the strength is. If I have a seam every 12 inches and I test it, I get a value. If I get a seam every 24 inches, it's usually half as strong as 12-inch seams. So if you have a wider pan panel, on average, it is going to be weaker than a narrower pan. So yes, I test a lot of 24-inch panels and 18-inch panels. Trap T, those are the two spacings, that we have. So yeah, I'm going to see the wider you go, the weaker it gets.
So, and that's interesting, right? Because the wider panel obviously installs quicker, can be more economical to purchase. And if your wind situation allows for that, then it's the perfect panel, right? But if you're in a very high wind situation, then that's where we start to see people come into those narrower pan widths. So... All right, so let's pivot a minute if we can here, Hunter. Why do we have our own test lab, right? It's obviously a fairly expensive investment, right? Between your time and the space and all of that.
We have to test our panels, period. All the manufacturers have to test for safety. You could choose to do that in-house like we're doing it here, or you can have it done out of house. We work with a company that does some testing for us. We have to have third-party testing, period. You can't test every single thing you produce in-house. There'd be some morality issues there that could crop up. But we do need testing out of house. But by having me on in-house doing testing, it's so much cheaper for us. I'm a great deal, even my wages and everything involved. It's a lot cheaper. And also, I work with McElroy. I do solely McElroy things. So when I have a product on hand, I know if it's correct or not a lot quicker than some of the other testing facilities. They'll just take the product and install it, and it is what it is. And we don't really get to see it unless I'm sitting there with them. So it's more rapid testing, cheaper testing, and I can change the testing a lot easier than telling a third party what to do with their chamber.
Yeah. And, let's dig into that. You just hit a little bit that it's more rapid. So talk to us about that. What do you mean by that?
Yeah. So typically, say we're doing testing with FM. FM is out of Rhode Island. We have to send material to them 6 months in advance.
Oh,
we have to set up the schedule for what the testing is going to be, and we have to fit into that time span of schedule. Well, we might, in 6 months' time, might not actually need that test. So it's easy to drop one, but if I needed to add in another one, then that's going to be 2 years from now before I can get into schedule with FM. For me out here, they just call and say, "Hunter, don't worry about testing the 238T. We need to take a look at medallion lock." And I go, "Okay," and that's it.
Right.
I'm in pocket, as it were. So I will change whatever I'm doing. Whenever and whatever, any new idea that comes out, I try to accomplish that.
I think that's a great point. As a company, it really allows us to pivot much more quickly. And it also allows us to reprioritize, to your point, right? Maybe we have somebody working on a huge job and it's got a construction method we don't have tested, right? Or a width or a gauge, all of those things. We can make a business decision. And I think that benefits both McElroy and all of our customers for sure. So.
Yeah, absolutely.
So, What else do you think our listeners today need to know about testing and what you do that we haven't already talked about, Hunter?
Some more things I do: product development, testing. I'm also, and it's becoming more and more of my job now, I do training. I do standing seam installation training for our certification for customers. I'm sorry, I shouldn't say training. No one can teach. No one can teach somebody everything involved with metal roofing. There's a lot to it, but I do certifications here, and I do it inside this facility as well. Product development, Stephen Knight and I, we sit down just about every morning and talk about, product development and where we're going with parts and pieces and stuff like that. And as far as testing go, what people need to kind of take away from it is that we are absolutely testing every single product that we put out there for safety, for reliability, and so that you can have confidence in the thing you purchased. When you install it, will perform as expected. You may not have this at a smaller manufacturers that they're bred, making a panel on site and putting it on a roof. There's no testing to that whatsoever. It's just a generic panel. You can stand behind McElroy that we have testing for these things.
Yep, I think that's a huge
it's valuable.
Point. Yeah, I think that's an absolutely huge point as our contractors and even building owners look to choose partners, right? They have a lot at stake. Sometimes it's their livelihood. Sometimes it's their safety of their employees. There are a lot of variables, and to work with somebody that has made the investment McElroy has in our testing and to give them the confidence in their building products is absolutely huge. So,
yeah.
All right.
Absolutely.
Well, we kind of at a point we should probably wrap up, Hunter. But before we do, tell us about your most memorable experience in the lab.
Ooh, let's see. We've had many, many very good explosions out here in the lab. That's probably the most fun that most people have. They want to come out and they want to see when the explosion happens. And for me, I'm standing there. I'm kind of nervous because I'm like, I don't want this to explode before, but I don't know when the optimal time is. So I'm always nose up to the blast shield. Watching it in a bated breath, making sure I didn't make any mistakes. So that's the most excitement I get, is when I'm worried that I've made a mistake here.
So you just mentioned a blast shield. We should tell our listeners what is a blast shield.
So we need to protect ourselves. We have a lot of pressure in a box that's being retained by metal panels, and when it goes, it has a lot of force. It can blow out. So we have a shield with Lexan glass on it and string gauges that come and they go down to the panel. We're standing behind this shield. So if anything were to ever come out, a clip, or really mostly it's fine particles of like drill, casting and stuff like that could blow in your eyes and things like that. So yeah, we stand behind a shield and we take measurements. There are some places I've gone to where they will go down with the panel and they'll take measurements with a ruler on the panel. I'm not that brave. I think we get to a lot higher pressures than some people do. So yeah. I want to be behind it,
Yeah, for sure. Well, thanks so much for joining us today, and thank you for making sure that our customers and building owners can rest confidently that their products are well tested.
Absolutely. Thank you for having me.
Yeah. Have a great rest of your day.
All right, you too.
Thanks for listening to the Building with Metal podcast, presented by McElroy Metal. To stay up to date with our latest episodes, be sure to subscribe wherever you get your podcasts. Visit us online at www.mcelroymetal.com for more info and products. Until next time, keep building with metal.